Welcome to today's lecture on adding and subtracting fractions. My name is Drew Collop. In today's lecture, we're going to talk about adding and subtracting fractions with like denominators. The denominator is the number in the bottom of the fraction. And this represents the parts that make up a whole. We talked about like denominators. This is when you have two different fractions and they have exactly the same number in the denominator. Let's start today by talking about how to add like fractions. I have a little process written down here. Step number 1, add the numerators together. These are the top numbers. Step 2, you keep the denominator the same. The denominator does not change. And students will make the mistake of adding the denominators. That is incorrect. Lastly, see if your fraction can be simplified any further. Let's put this process in play now. Double check. Make sure they are like fractions. You can see they both have a denominator of 5. Then they are like fractions. We look at the numerators and we add those together. 3 plus 4. We keep the denominator the same. And then we make that 7 over 5. If you wanted to, you could turn this into a mixed number, 1 and 2/5. This math is the simplest math you have when you're working with fractions. But we want to make sure that everyone understands what we're doing. Let's try the next one together. You can see here, these are all like fractions. Why? Because they all have the same denominator of 8. We then look at the numerators and we add those numbers together. 7 plus 3 plus 2 over 8. Now there's no need to do this step. Hopefully you can just add them in your head, but I want to make sure you know what I'm doing. Next up, 7 plus 3 is 10 plus 2 is 12. 12 over 8. We can simplify that down. Hopefully you see we can take a 4 out of the top and a 4 out of the bottom. In which case here, this becomes 3 over 2. This is in simplest form, but it is an improper fraction. The numerator is larger than the denominator, so we can convert that to a mixed number of 1.5. There really isn't much more to adding like fractions than what we've shown here. First of all, see if they have the same number in the bottom, and just add the tops together. Let's make it a little bit more difficult, though. Let's talk about a word problem. Word problems can be a challenge. And in the laboratory, every lab protocol you get is technically a word problem. You have to read it over, try and figure out what it's asking you to do, pull out some sort of mathematical relationship, create those formula. So here's some steps along the way. Step number 1, read the problem carefully. Too often students don't read carefully. I shouldn't say just students, really anybody can fall into this trap. You don't read the words that are there. Sometimes you assume you think you know what it says when you actually don't. So make sure you're reading carefully. One piece of advice I can give you is underline important words or bring a highlighter and highlight words of importance. Number 2, determine what you are given and what you're asked to find. Quite often, you're given more information than you actually require. Too often, students don't answer that specific question. They answer something else because they didn't read the question properly. So read it thoroughly, make sure you know what you're given, make sure you know what you're being asked to solve at the end. Step number 3, convert all of these words into some sort of mathematical relationship. Step number 4, do the calculation. Look at that. Step number 4, this whole part here is just the math. Everything else is something else. Ask yourself, is this answer reasonable? I'm weighing out 1 gram on a scale and I add half a gram and my calculation says I get 50,000 grams. Does that sound reasonable? I can't tell you how many times students write something like that down. They don't think about what it actually means and they just make an error in their calculator and they just write the number down. So when you get your answer, if it's a word problem related to something in the real world, try and ask yourself, does that specific thing make sense? Lastly, write your answer in a statement, making sure you indicate the units. Units in this course is going to be extremely important. When you're working in a laboratory, units must be expressed. If there's no units, the number doesn't mean anything. What if I said to you, I'm going to pay you 7 to clean my washroom? What does that mean? 7. There was no units on that. Going to pay you $7? You're going to say, no, thank you, sir. Not enough money. If I say 7 gold bars, see how the units changes the value completely. Make sure when you're reporting numbers, especially in the laboratory, there's always some sort of unit associated with it. Let's apply these principles to this word problem. A student weighed 2 over 15 grams of salt on paper, and the paper weighed 7/15 of a gram. What was the total weight? Read the problem carefully. Student weighed this much salt, and on the paper, it weighed this much. So we have two different things. We have paper and we have salt. What's the total weight? So I'm asking the total, so I have to add this up. This is an addition question. Now let's convert this to a relationship. So I have 2 over 15 plus 7 over 15. And I have to solve that. That's equal to something. What did I not write down here? I did this on purpose. I didn't write the units down. When you're doing calculations, if there's units in there, please place your unit into your calculation. That's extremely important because in order to add these up, these must be the same unit. If this unit here was in milligrams, we must convert milligrams to grams and then solve it. So make sure before you add up or subtract values that are fractions, or any number in that case, make sure you're adding numbers that are the same units. These are like fractions. They have exactly the same denominator. So we know that value doesn't change. We add the numbers on the top. I'll just write it down, 2 plus 7. And I'm going to transfer over grams here because that's the final units. And then 2 plus 7 is 9 over 15 grams. And we can simplify this down, of course. I can take a 3 out of the top. I can take a 3 out of the bottom. When I do that, I get 3 over 5 grams. We're not done yet. Ask yourself, does this make sense? Is this reasonable? Doesn't seem like too much. It's they're very small, 2/15, 7/15 of a gram, both low quantities. And 3 over 5, that seems low as well, but slightly larger than, say, 2 over 15 or 7 over 15. So that looks pretty reasonable. Lastly, give yourself a statement at the end. 3 dots like this. This means therefore. Therefore, the total weight was 3 over 5 grams. And ask yourself, was that what I was being asked for? I wrote down the total weight, and that's what I was asked for, the total weight. Always double check that. Did you solve what was being asked of you? Maybe you did a lot of work. You worked hard and you got an answer. If it's not what's being asked of you, you wasted all that time. We did the process of adding like fractions. Now we're going to do the process of subtracting like fractions. Step number 1, make sure they're like fractions. Make sure that the bottom number is the same. Step number 2, look at the numerators. Subtract one away from the other. Keep the denominator the same, then simplify. Same as before, except now we're subtracting. So we double check here now. You can see 9 and 9, same denominator. These are like fractions. Now we're going to do 7 minus 3. The negative sign is associated with the 3 over 9. So the negative sign comes along with that. So 7 minus 3 over 9. 7 minus 3 is 4 over 9. Then ask yourself, can I simplify that down more? No, I cannot. So that's the final answer. Next up, we have 16, 16, and 16. These are like fractions. So I'm going to place it over a common denominator. And then I'm going to look at the numerators. 15 minus 7 minus 3. 15 minus 7 minus 3. That's the math we're going to do. Pool them all together. 15 minus 7 is 8. And then lastly, 8 minus 3 is 5. 5 over 16. Can I simplify that down anymore? I cannot. As a result, that is the final answer. Once again, this is very simple. You keep the denominator the same, and you do the math on the numerators, whether it's addition or subtraction. Let's talk about common multiples. What is a multiple? A multiple of a number are the product of itself and another number. So here we have multiples of 4 would be 4, 8, 12, 16, 20, so on and so forth. We're talking about 4 times, in this case, 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, and so on and so forth. 4, 8, 12, 16, 20, these are all multiples of the number 4. That's not so important. What's important is a common multiple. These are multiples of more than one number in a group of numbers. What's very important is the lowest common multiple. This is going to be very important for fractions. So let's look at two numbers. We have 4 and we have 6. This will be our small group, 4 and 6. What are the multiples of 4? Well, we have 4, 8, 12, 16, 20, 24, just multiplying as we move up. And for 6, 6, 12, 18, times 4, times 5, times 6, times 7, times 8, so on and so forth. What are the common multiples between 4 and 6? Well, we have 12. We have 36. I missed 24. We have 48. So these numbers, 12, 24, 36, and 48, are common multiples of 4 and 6. But only one of them is the lowest. Which one's the lowest? 12 is the lowest common multiple. You can see it here. It is the lowest number between all of them. If you had to do this every time you had to find a common multiple, this would take a lot of effort. So there's an easier way to do it. I'm going to do it right now, and then I'm going to explain it. So what we do is we take all the numbers in our group. Here I said the two numbers were 4 and 6. What I'm going to do now, I'm going to break these numbers down into their prime numbers. Remember what a prime number is. A prime number, you can only get it by multiplying by 1 and itself. So 1, 2, 3, 5, 7, 11, so on and so forth. Let's break down 4 and 6 into its prime numbers. 4 is going to be 2 times 2. 6 is going to be 2 times 3. If the numbers are the same under this method, we put them in the same column. So this is the same, 2 and 2. But look next, we have a 2 and we have a 3. So if they're different, we don't line them up. We give them their own separate columns. So in this case here, I've created 3 columns. What I then do, I just move these down. So this is all 2. I bring 1, 2 down. This is a 2. I bring that down. This is 3. I bring that down. I multiply these together. 2 times 2 is 4. Times 3 is 12. So this method here is a simple method to get the lowest common multiple every time. You might say, sir, that's not simple. I can do this in my head. Well, when we get to much larger numbers, it's very difficult to do in your head. This process is called prime factorization. That's its name. You don't have to memorize the name. All I want you to do is understand how to do it. So step number 1, write all the numbers of interest in a column. Step number 2, break each number down into its prime numbers, multiplying them together to get that answer. Step number 3, common prime numbers are placed in common columns. Step number 4, numbers that are not common get their own columns. Step number 5, at the bottom of each column, bring down the numbers. Step number 6, multiply these numbers together, and voila, lowest common multiple, guaranteed, if you've done it correct. Let's try and find the lowest common multiple of 18 and 24. We write down those numbers here, 18, 24. I break down 18 is what? 9 times 2? Well, 9 is not a prime number. So here I've written 2 and 3 and 3. 24 is what? 12 times 2. Well, we have 2. 12 is not a prime number. We can break down 12 into 2 times 2, which is 4, and 3. What we then do is we've written the numbers like this so that they're common. These get their own columns like that. I then bring this down, bring this down, bring this down, bring this down, bring this down. And then I multiply all the numbers together. We have 2 times 2, which is 4, times another 2, which is 8, times 3, which is 24, times 3, which is 72. 72 is the lowest common multiple of 18 and 24. I'm pretty sure you couldn't do that in your head. You might be asking yourself, sir, why do I care about the lowest common multiple? Okay, we have 3 over 18 plus 7 over 24. Solve it. Well, we talked about like fractions before, where the denominator had to be the same number. This is a way we can convert these to be the same number. We want to convert them to become the lowest common multiple. That is why we're doing this. Let's work on A together, and then I'll give you time to practice with B. Or if you choose, you can pause your video and you can try A and B on your own. So step number 1. So we want to find the lowest common multiple of 9, 18, and 30. Let's break down 9 into its prime numbers. 3 times 3. 18, I know that's 9 times 2. That's going to be 3 times 3 times 2. And the 3's are the same, so I line them up in the same column. Now 30, I know that's going to be 3 times 10. So I can write the 3 here. But I can't write 10 here. Number 1, it doesn't line up with the 3's. Number 2, it's not a prime number. So 10 can break down into 2 and a 5. So I line up the 2 here, and I line up the 5 here. Now, if you notice this, if you just work back, if you've done it right, 3 times 3 is 9, 3 times 3 times 2 is 18, 3 times 2 is 6, 6 times 5 is 30. So if you want to double check if you did it right, just go back and multiply those numbers together. We then set up the columns here with the common numbers, and we bring down those numbers. We bring down 1 3 here. We bring down another 3. We bring down another 2. We bring down another 5. What do we have here now? 3 times 3 is 9. 2 times 5 is 10. 90 is our answer. So the lowest common multiple of 9, 18, and 30 is in fact 90. I'd like you now to pause your video and try and find the lowest common multiple of 5, 12, and 16. Try that now, then we'll take it up. 240 is the correct answer. If you got that, that's wonderful. If you didn't get that, then please pay attention and hopefully you'll understand after I take it up. The groupings of numbers we have are 5, 12, and 16. I write them down. It doesn't matter the order you write them in. I always write them the lowest number on the top and the largest number on the bottom. That's just how I do it. 5 is a prime number. Remains there. 12 is going to be, 3 times 4. But 4 is not a prime number. Let's break it down into its prime numbers. 3 times 2 times 2. Next up, 16. Well, 16 is 4 times 4, but 4 is not a prime number. So I'm going to write 2 times 2 times 2 times 2. Now notice, I've lined up numbers that are similar, but numbers that are different. I put them in their own columns. So 5 gets its own column. 3 gets its own column. These 2 share a column. These 2 share a column. These 2's get their own column. We bring the numbers down now. 5, 3, 2, 2, 2, 2, and we multiply them all together. In this case here, 5 times 3 is 15, 2 times 2 is 4, and 2 times 2 is 4, giving me in this case, what do we got that? 15 times 4, that's going to be 60 times 4. 6 times 4 is 24, so 60 times 4 is 240. You can see here the lowest common multiple of 5, 12, and 16 is 240. I bet you couldn't do that in your head. I know I couldn't. So hopefully now you understand how to determine the lowest common multiple. Again, why would you ever want to do this? Well, what if we had 3/5 plus 4/12 plus 2/16? We'd have to turn these all into common denominators. What's going to be the lowest common denominator? It's going to be the lowest common multiple. This is for another class though. For now, let's just focus on determining what the lowest common multiple will be. The last concept for today's lecture is going to be comparing fractions. We look at 3/5 and 2/9. Which one's the larger one? Hopefully you can imagine what 3/5 looks like and what 2/9 looks like. Imagine you have a pie and it's divided into 5 equal parts and you get 3 of those 5 parts. As opposed to another pie that's divided into 9 parts, you only get 2 of them. So hopefully you can visualize that 3/5 is a bigger number than 2/9. But that's visualization, and maybe you're not very good at that. One thing we can do to compare fractions, we can have denominators that are the same, like fractions. Remember from the beginning, we're adding and subtracting like fractions. So how do we convert 3/5 and 2/9 so they are like fractions? Well, let's work with prime factorization. Let's find out what the lowest common multiple is. We'll write down what we're given, 5 and 9. Break that down into its prime numbers. 5 is a prime number. 3 times 3 is the prime numbers here. Bring these numbers down. 5 gets its own column. The 3 and the 3 get their own column. We have 5 times 3 times 3. Work this out. 5 times 9, which is going to be 45. So the lowest common multiple between 5 and 9 is 45. Now, whenever you have two numbers, You can get a common multiple by just multiplying them together, but you don't always get the lowest common multiple by doing that. So I would advise you to always try and do prime factorization to get that lowest common multiple. So what do we have to do now? To get the 5 to become a 9, I got to multiply the bottom by 9. Now remember this from before when we were simplifying fractions. I can do whatever I want to a fraction if I do the same thing to the top and the bottom when I'm talking about division or multiplication. So by doing 9 on the bottom and 9 on the top, I haven't changed the value of this fraction at all. Likewise, to turn this 9 into 45, I multiply by 5. And I must do the same thing to the top. Now, we work it out. We know on the bottom, this is both going to be 45. That was the whole purpose. We want to have like fractions. Now what do we get on the top? 3 times 9, 27. 2 times 5 is 10. Now you can just look at the top numbers. 27 and 10. Which one's bigger? 27 over 45 is greater than 10 over 45. Or what else I could say? 3 over 5 is greater than 2 over 9. Honestly, in this course, we're not going to be doing a lot of comparison of fractions. And in the real world, you're not really going to either. However, in the laboratory, you're going to be working with fractions quite a bit. And being able to find the lowest common multiple and convert both those fractions so they have the same denominator, that's a key skill to have. So I've written out the process here. I guess I've already done it. Let's just review the process in case you get stuck and you need to go back and remind yourself. I guess these videos exist, so you could just watch the video again. Converting fractions so they have like denominators. Step number 1. Determine the lowest common multiple by using prime factorization. This method here. Step number 2. Whatever this number is, it becomes the lowest common denominator. So this was the lowest common multiple, and this becomes the lowest common denominator in my fractions. Step number 3. Determine the value that each denominator must be multiplied by to obtain the lowest common denominator. So here it was 9, and here it was 5. And as long as I do the same value on the top of the fraction and the bottom of the fraction has the same value. It doesn't change the value, it just changes how that value is expressed. Step number 4. Whatever number the denominator is multiplied by, multiply the numerator by that same number. Remember what I just said? Make sure you multiply the top and the bottom number by the same number. As I stated, the value does not change if you multiply both the top and the bottom by the same number. Multiply by different numbers or divide by different numbers, you change the value. Don't do that. We have 3 practice problems to finish off today's lesson. I'd like you to pause your video. I'd like you to compare these. Tell me which one is larger with a greater than or less than sign. To do that, convert them so they are like fractions. They have the same denominator. Do prime factorization, find out what the lowest common multiple is. That lowest common multiple becomes the lowest common denominator. Find out what numbers you have to multiply the bottoms by to get that lowest common denominator. Whatever number you multiply the bottom by with that specific fraction, multiply the top, the numerator, by that same number, and then compare the numerators. Give that a try now. Let's take them up real quick. There, and there. That's what they look like. But that's not enough. Let's go through and actually solve them with you. So what do we have here now? We have 8, we have 10. Break down 8 into its prime numbers, 2 times 2 times 2. 10 into its prime numbers, 2 times 5. Remember, the 5 goes off on its own. Here we have 8 times 5, which in this case is 40. So 40 is going to be my lowest common multiple, which becomes my lowest common denominator. To get 10 to be equal to 40, multiply by 4. Multiply the top by 4 as well. Here, to get 8 equal to 40, multiply by 5. Multiply the top by the same number as well. What we then get is 25 over 40, and here we get 28 over 40. Which one's bigger? 28 is bigger. 25 over 40 is less than 28 over 40. Next up, 5 over 6 and 6 over 8. Do prime factorization, break down the 6, 2 times 3, break down the 8, 2 times 2 times 2. Remember, like numbers go in the same column, and numbers that are not alike go in their own columns. What do we have here now? 6 times 4, which is 24. So 24 is the lowest common multiple between 8 and 6. To get 8 equal 24, multiply by 3, multiply 6 by 3, to make sure we don't change the value of the fraction. To get 6 equal to 24, we multiply by 4. Multiply the top by the same number. 5 times 4 is 20, 6 times 4 is 24, 6 times 3 is 18, 8 times 3 is 24. Which one's bigger? 20 is bigger than 18. So 20 over 24 is greater than 18 over 24. Last question of the day. 9 and 6. 9, actually I said I always write the big number on top. 2 times 3, 3 times 3. Bring those down. 2 times 3 times 3, which is what? 2 times 9, which is 18. 18 is the lowest common multiple, so 18 is going to be the lowest common denominator. How do we get 6 equal to 18? Multiply by 3, multiply the top by 3. How do we get 9 equal to 18? Multiply 9 by 2, multiply the top by 2. 14 times 2, 28 over 18, and 10 times 3, 6 times 3 is 18. Make sure you read that appropriately. There we go, 30. You can see 30 is bigger than 28, so 28 over 18 is less than 30 over 18. So in today's lecture, we started examining adding and subtracting fractions, just looking at like fractions. Like fractions have a common denominator, the same number in the bottom of the fraction. We spoke about how to solve word problems efficiently. We talked about prime factorization, how to get the lowest common multiple. And we talked about comparing fractions, how to convert two fractions that don't have a common denominator so that they do have a common denominator. Again, the steps are look at the denominators, do prime factorization on all the numbers involved, convert those denominators over by multiplying by whatever you need to. Whatever you multiply that specific denominator by, make sure the associated numerator is multiplied by the same value. In that case, you will have all like fractions in that case. That's all for today. Until next time.